Walaikum salam. How are you guys? Last video of binomial. I'm not sure what you mean by that. Walaikum salam. I'm good. How are you? Let me turn on my camera also. So, how's the preparation for tomorrow? Obviously, talking to those who have their exam tomorrow. Tomorrow is ASP1. Yeah, I heard tomorrow is ASP1 as well as AdMaths paper 1. If someone scores a B in AdMaths, is that considered good or bad? Well, B is not that bad a grade, but if you have the potential of scoring an A, why settle for a B? Okay, so let's begin, shall we? So the objective of today's class is, as you guys can see, functions. Okay, so this is perhaps one of the most requested topics there is, and I can understand why. It's challenging, yes, and there are a lot of concepts to learn in this topic. Okay, so hopefully you're like as you can probably judge by the title of this video, in this video we're going to be doing past paper. So if you feel like your concepts are not up to the mark, okay, that's okay, it's nothing to worry about. Once we do enough past paper questions, inshallah, you will feel like you have a good grip on it. Okay, so let's start. So I will mention each and every question that I solve, and I will also try and solve every question in detail. Okay, all right. So here's a question which is from May June 2017, paper 1, variant 1. Okay. Sir, do you have any video on permutation and combination? Yeah, I think I do have a video on permutation and combination. I did a live stream a couple of days ago. That's not a concept, I agree. That was past paper live stream. But I think I do have a video on permutation combination. Anyway, so let's see what it says. So it says it is given that f of x is equals to 3e to the power minus 4x plus 5 for x is an element of all real numbers. State the range of f. Now you can see that this is a 1-mark question. There's not a lot of space provided to you over here because the examiner is expecting you to know this question very well. And if you do, then you would straight away know that the answer is greater than 5. Okay, but if you don't, that's okay. I'll quickly explain. So regarding exponential functions, if you look at the graph of an exponential function, any exponential function for that matter, okay, so this is what it looks like. So here's x and here's y. Okay, at 0 it's equal to 1. As we know, anything raised to the power of 0 is equals to 1. Okay, and the further you go towards the left hand side of the y-axis, okay, or towards the left hand side of the x-axis, the graph becomes very close to 0, but it's actually never equal to 0. So as far as e to the power anything is concerned, the range of that is that it's always greater than 0. Okay, so e of x, remember, is always greater than 0. So what happens if you add 5 to it? If you add 5 to it, so think of it this way. Now the graph has moved 5 units upwards, okay? And if the graph has moved 5 units upwards, so that means the range of this graph will now be f of x is greater than 5. Okay, so that's it. Not a lot of work that needs to be done over here. Just f of x is greater than 5, because the least that this can be is not actually 0, but it can be greater than 0. So what if there's a value that's greater than 0 and you add 5 to it? Overall, the value becomes greater than 5. Okay. What's the role of 3 in it? Okay, so the role of 3 is not really going to change anything. Okay, it's not going to have any effect on the range. Yes, as far as the shape of the graph is concerned, that there will be some effect on it, but overall there is no role of 3. It's not going to change the range as far as the range is concerned. Okay, all right, then comes part 2, which says find f inverse of x and state its domain. Okay, so what are the 2-3 steps that we need to know in order to find the inverse? No, it's not like the amplitude. Amplitude is only for trigonometric functions. Okay, all right, just a second, need to ban a few. Okay, yeah. Now, so f inverse of x, what's the first step? The first step is that we do y is equals to 3 e to the power minus 4x plus 5. Okay, the next thing that we do is we try and make x the subject. Okay, so how do we do that? We do that step by step, of course. So y minus 5 is equals to 3 e to the power minus 4x. Is x the subject yet? Nope, not yet. Okay, now what about now? What's the next thing that we do? The next thing we do is y minus 5 over 3 is equals to e to the power minus 4x. Okay, so we're almost there. Okay, but not quite there yet. So next thing we do is we write this nicely. This is a 4-mark question. Okay, so that means there is some work that needs to be done. Y minus 5 over 3. Now how do we get, yes, we take ln on both sides. So we take ln on both sides. The objective, remember, is so that we can bring x from the power to have it multiplied by the exponential function. So ln e to the power minus 4x is equals to ln y minus 5 upon 3. Okay, what's the next step? The next step is we ln e is equal to 1, so minus 4x is equals to ln y minus 5 over 3, and now we make x the subject. So if I make x the subject, what happens now is that this becomes ln y minus 5 over 3 divided by minus 4. So quick question for you guys, what happens when you go from division to multiplication? What do you do? If you change it from division to multiplication, what happens? And while you guys give me the answer to that, just give me a minute. I will open up the answers here. Okay, yes, you take the reciprocal. Okay, so x equals to what? X is equals to ln y minus 5 over 3 into minus 1 upon 4. Okay, so what's next is that we make x the subject. So x, well, there are a lot of ways through which you can write this. Okay, so I would prefer to write it like this: minus 1 upon 4 ln y minus 5 over 3. Now remember the last step, and the last step is that you write f inverse of x, which is equal to minus 1 upon 4 ln, minus 1 upon 4, and then comes ln x minus 5 over 3. Okay, now what's the final step? That's it, that's the final step. But how do we write down the domain? Okay, considering that we already know the range of f of x and we already know the domain of f of x, so how do we write down the domain for f inverse of x? Question for you guys. Think about it, go over the solution to the previous part and tell me. And while you guys do that, just give me 1 minute. I'm gonna open up the answers here. Okay, let's see what you guys have said. Yes, so range of f is equals to, okay, no, wait a minute. Since the question is asking for the domain, okay, remember, domain of f inverse of x. Okay, so I'll write it down over here. range of f of x is equal to domain of f inverse of x. Okay, range of f of x equals to domain of f inverse of x. Now notice that we already have the range of f of x, so that means x is greater than or equal to 5 is going to be the domain. So there you go, that's your final answer. Okay, now that's that. Moving on to part B. Let's see what part B says. So part B says it is given that g of x is equals to x squared plus 5 and h of x equals to ln x for x is greater than 0. Solve h of g of x equals to 0. Okay, so help me out here. What do we do? Do we plug in g in h or do we plug in h in g? Question for you guys. This is from May June 2017, paper 1, variant 2. Paper 11 actually. Yep, we plug in g and h. Okay, so let's do that. Let's plug in function g and function h. Okay, so plugging in g in h means that we have ln. Now in place of x, remember what we are going to have is g of x, which is basically x squared plus 5. Okay, so there's no need to make these gigantic brackets here. So x squared plus 5, and what is this equal to? This is equal to 2. Okay, so I'll repeat what I've done. So when it says h of g of x, so here's what we've done. In function h, we have replaced x with g of x. Okay, so how do I solve this now? Okay, so this is how I solve this. What is the base of ln? The base of ln is e. Okay, so we write this in index form, which means x squared plus 5 is equals to e to the power of 2. Okay, and then we write this nicely. X squared is equals to e to the power of 2 minus 5. And we make x the subject, for which we'll have to take the square root on both sides, and now we have e squared minus 5. Now remember, you will get two answers, one positive and one negative, but because the question here says for x is greater than 0, that means the only answer that we will give is the positive one. So you have e squared minus 5, close the bracket, and now you have x equals to 1.545, which we will lock at 1.55. There you go, that's the answer. Okay, so that's that. Hopefully you guys have understood what I've done so far. And here's another question. This is from May June 2017, paper 2, variant 2. Okay, let's see what it says. So it says the function g is defined by x is greater than minus 1 over 2. Okay, so that's the domain of the function, by g of x. And let's see what it says. So it says show that g prime of x is always negative. Okay, how do we show that? How do we show that g prime of x is always negative? Question for you guys. Okay, I want you guys to try and do the first and the second part. I'm just going to take a 2-minute break and I'll be back. Okay, now alright, so did you guys manage to solve this question? The first part where it says show that g prime of x. By the way, what does it mean when it says g prime of x? Yes, g prime of x means that we're going to differentiate it. Okay, so let's differentiate this. Let's see what we get. So when we're differentiating it, there's no need to use the quotient law. Okay, you can just take 2x plus 1 in the numerator, so that way you get 2x to the power minus 1. All right, this is g of x. Now when you differentiate it, notice what happens. Differentiating it means that this becomes minus 3, okay, into 2x to the power plus 1. Minus 1 becomes minus 2, and then you multiply it by the differential of the bracket, which is equal to 2. And let's see what happens now. So now what you're looking at is g prime of x, which is equal to minus 6 over 2x plus 1, the whole thing squared. Okay, now why do you think this function is always going to be negative? Think about it. Why do you think this function is always going to be negative? Yes, minus 3. It's actually not minus 3, it's minus 6, but I get what you're saying. So basically, as far as the denominator goes, so denominator is always positive, okay? Denominator is always positive, and numerator is minus 6. Okay, so what do you do when you have a negative number divided by a positive number? The answer will always turn out to be negative. Okay, there's no need to write down a very extensive explanation. Okay, just showing that the denominator is always positive is enough, and just showing that and also showing that the numerator is always negative, that's enough. Okay, all right, then it says write down the range of g. So what do you think will be a range of a function like this? Think about it. And what do you think will be the range of this function? So, and also bear in mind that the least value that you can plug in, actually, also bear in mind that the domain of this is greater than minus half. Okay, so think about it. Do you think the denominator will ever be a negative value, considering that the value of x that you're plugging in is basically minus 1 over 2? Do you think the denominator will ever be negative? Okay, I'm not talking about g prime of x. Remember, I'm talking about g of x. Okay, so let's start by plugging in minus 1 over 2. Okay, so if you plug in minus 1 over 2, you actually can't do that. You get an error because the denominator becomes 0. Okay, now anything that is less than minus 1 over 2, let's say minus 1 or minus 2, will lead to the denominator being negative. Okay, so pay close attention to what I'm saying. If you plug in a value that is less than minus half, let's say you plug in minus 1. Okay, so as we speak, I'm plugging in minus 1. So if I plug in minus 1, what we get is we get minus 3. Okay, now if I plug in, let's say 0, okay, so what we get is 3. All right, so that means if whatever value that I plug in, the least that this will be positive. Okay, it can never be negative. Okay, the least that this can be is 0. Okay, and it's not going to be exactly equal to 0, it's going to be close to 0. That is when the denominator becomes extremely large. And what happens when you have a fixed value divided by extremely large value? It is basically very close to 0. So as far as the range goes, the range of this is simply going to be greater than 0. So g is greater than 0, and that's it. That's your answer. So can you do a graph question after? Yeah, I'll try and do a graph question also. Okay, maybe there's a graph in this question also, but anyway, hopefully we'll come across graph questions also. Anyway, so it says the function h is defined for all real x by h of x equals to k of x plus 3, where k is a constant. Find an expression for h of g of x. Okay, so h of g of x basically means that you have function h, and in it you're supposed to plug in g of x, and that's it. There's no simplification or anything that's required, so we'll just leave it over there. So h of g of x, so k, and x we're replacing with function g, so that's 3 times 2x plus 1 plus 3, and that's it. That's where part 3 ends. It's a 1 mark question, so there's no work that's required. Part 5. Part 5 says, given that h of g of 0 equals to 5, find the value of k. Okay, so considering that you already have h of g of x, how will you find h of g of 0? Well, you can do that by simply plugging in 0 in place of x. Okay, or you could do it like that you could first find out g of 0, and you could plug that value in function h. Okay, so let's see, if I plug in h of g, if I plug in 0 in h of g, so here's what happens. K as it is, okay, 3 as it is, 2 in place of x, now we have 0, there you go, plus 3, and this becomes what? This becomes 3k over 2 into 0, so that's 0, plus 1 plus 3, and that's equal to what? That's equal to 5. Now let's solve this. Let's see what we have. So we have 3k plus 5, which is equal to 3. So that means 3k is equals to 3 minus 5, so that's minus 2. So k is equals to what? K is equals to minus 2 upon 5. And there you go. That is, no, wait a minute. I think I've done something wrong here. Oh, sorry, it's minus 2 upon 3, not minus 2 upon 5. It's minus 2 upon 3. And that's it. That's your answer. Nothing to worry about. Okay, then it says domain of h of g. Okay, so notice how the question was kind in the sense that it already made us find out the value of k, and it already made us find out h of g. So now h of g is basically this function. H of g is basically 3 into k over 2x plus 1 plus 3. Okay, so whether we know the value of k or not, it doesn't really make a difference. But what do you think should be the domain of this function? Think about it. What do you think should be the domain of h of g? Considering that k is equals to minus 2 upon 3, so let's replace that. Let's find out h of g. So 3 into minus 2 upon 3, okay, over 2x plus 1 plus 3. So this and this gets cancelled out, and let's see what do we have. We have h of g, which is equal to minus 2 over 2x plus 1 plus 3. Okay. Domain are basically the values of x that you can plug into a function to keep the function defined. Okay, so that's what domain is. All right, now part 5 question for you guys. What should be the domain of hg? Okay, anyone else? And may I know why you're saying that? Yeah, that is true. Okay, so basically what we have over here is thank you. Acha. So basically what we have, wait, you can't see me? Okay, I think I accidentally pressed one of the hotkeys. Okay, yeah. So basically what we have over here is we have a function which sorry about that. Yeah, sorry about that, sorry about the echo, and sorry about the camera disappearing. Anyway, so basically what we have ourselves is a function, okay, in which we have a denominator 2x plus 1, and in this you got to make sure that the denominator is never equal to what? The denominator is never equal to 0. Okay, so if you want to make sure the denominator is never equal to 0, that means x has to be greater than minus 1 over 2, and there you go, that's your domain. Okay, all right, so that's that. Moving on. So here's an interesting question. Okay, let's see what it says. And by the way, just to let you guys know, made a small calculation error over here. I think someone pointed that out earlier also, that this is actually going to be equal to 2 upon 3, not negative 2 upon 3. And because of that, this will be plus 2 and not negative 2. Anyway, I think someone pointed that out earlier. Thank you. Okay, so here's another question. This is an interesting question. This is from May, June 2018, paper 1, variant 1. Okay, paper 11 basically. So it says the diagrams A to D show 4 different graphs. In each case, the whole graph is shown and the scales on the 2 axes are the same. Okay, yes, this video will be uploaded, so don't worry about that. Okay, so place tick in the boxes in the table to indicate which descriptions, if any, apply to each graph. There may be more than one tick in any row or column of the table. Okay, so you guys know the vertical line test, the horizontal line test, and all of that. I hope you guys do. Okay, so what is the vertical line test for? So let me ask you guys, what's the vertical line test for? Yeah, what is the vertical line test for? So vertical line test is to check whether the function is a function or not. Okay, so let me write this down. The vertical line test is for function. Okay, so if a line passes the vertical line test, if a line cuts the vertical line only, if a curve cuts the vertical line or a vertical line cuts the curve only once, that means it's a one-to-one function. Okay, so and if let's say you have a horizontal line test, Okay. So the horizontal line test is for inverse. Okay, and it's not just for inverse, it's also for checking whether it's a one-to-one function or not. Okay, so let's do that one by one over here. Okay, so we know very well that a quadratic function, yes, it is a function, but it's not a one-to-one function. Okay, so a quadratic function is a function, but it's not a one-to-one function. Okay, so part A is a function, all right, but it's not a one-to-one function. Okay, but it is a function that has, what do you think? Part A is a function that has an inverse, yes or no? It's not a one-to-many, it's actually a many-to-one function. Okay. So let's take a look over here. A. Have a good look at A. It is a function, okay. It's not a one-to-one function, all right. A function that is its own inverse? Not really. Okay. A function with no inverse. Yep, that's correct. So as far as part A goes, it's a function that has no inverse. We know very well that there are some changes that we need to make to the domain of a quadratic function to make sure that it has an inverse. How would you know if it has an inverse? Okay. So inverse only exists if a function is a one-to-one function. Okay. I repeat, inverse only exists if it is a one-to-one function. All right, then we move to function B. So function B does not pass the vertical line test, meaning that the vertical line is cutting this function at two different points. So what do we say? We say it is not a function. Let's see if it's, well, if it's not a function, it's definitely not a one-to-one function. It's definitely not a function that has its own inverse. Okay. Now, let's talk about C. So as far as C goes, it is a function. All right. Okay. It's a function, so we put a check mark over there. Oops, sorry. It's a one-to-one function, so we put a check mark over there. It's a function that has its own inverse. Okay, you think that's true? You think part C is a function that has its own inverse? What do you think? Think about it. Yes, it is. It is true. Part C is a function that has its own inverse. Now, how do you check? I'll tell you how to check. So basically, the way to check is, remember, whenever you're finding out the inverse of a function, so how is a function and its inverse, how are they related? They're related in such a way that every point on the original function is basically a reflection of the inverse. Okay, or in other words, every point on the inverse function is a reflection of the original function. Okay, so if you look at this graph right here, you will notice that if you take this half of the function, the half that I'm highlighting in green, this is actually a reflection of this half. Okay, and vice versa. So that means this function that you're looking at in part C, whatever it is, so it's basically its own inverse. If you have this function and then if you find out its inverse, you will notice that there's no different at all, because one half is a reflection of the other. Okay, so through that we conclude that it is a function that has its own inverse. Okay, then we come to part B. Part D. Let's see what part D says. So as far as part D goes, if you make a vertical line, you will notice that this function is a one-to-one function. All right, and it is a function. It's a one-to-one function. So we just put a check mark over here, and that's it. There you go. End of story. This was a pretty easy question. 4 marks, 4 easy marks. Okay, I will re-explain about the vertical and the horizontal line test. So a vertical line test is to check whether it is a function or not. Okay, it is not going to tell us whether it's a one-to-one function or a many-to-one function. Okay, for that we have a different test. Okay, so a vertical line test is only to check whether it's a function or not. Then the horizontal line test is basically a test which further tells us whether it is a one-to-one function or not. And remember, whenever you have a one-to-one function, only then do you have its inverse. Okay, so notice over here that the only time that we have sort of checked this box, actually no, that doesn't apply over here, never mind. But remember, it's only a one-to-one function that will ever have an inverse. Okay, a many-to-one function will not have an inverse. All right. Okay, so here's question number 4. So I think I'm going to skip question number 4 because it's not too relevant. I mean, there's not exactly a new concept in question number 4. Let me pick some other question. Okay, let's solve this question. This is from, let me show you. This is from Major 2019, paper 2, variant 2. Okay, so it says the functions f and g are defined by 5x minus 2 and okay, graph. Yeah. Okay, I'll solve a graph question after this one. Okay, don't worry about that. F of x is equal to 5x minus 2, and you can see that you're given the domain which is greater than 1, and it says g of x equals to 4x squared minus 9, and you can see the domain is greater than 0. State the range of g. Okay, so it's always a good idea to first get familiar with the function that you're dealing with, even if it's a 1-mark question. So if you look at g of x, it's a quadratic function, okay? And you should know very well how to sketch a quadratic function. So 4x squared minus 9 is a quadratic curve that's going to have y-intercept minus 9. In fact, its turning point is going to be at 0, minus 9, okay? And if you quickly solve for the x-intercepts by setting it equal to 0, 4x squared minus 9 equals to 0, x squared is equals to 9 upon 4. Now, I know this is not really asked in the question, but it's just going to help you get familiar with the whole function. So the x-intercepts are plus and minus 3 upon 2. So positive 3 upon 2 and negative 3 upon 2. So that means the graph looks something like this, okay? Now, bear in mind, because of the domain, we're not looking at the entire graph, okay? The domain is x is greater than 0. That means the only part of the curve that you and I are allowed to look at is this part. So if you and I are looking at this part of the curve, okay, what would you think the range of this curve would be, considering that the turning point or the y-intercept is at minus 9? So question for you guys, I've made it a lot easier for you to answer now. And tell me, what do you think will be the range? What will be the range of this function if you were only allowed to look at the part that I've highlighted? Yes, that's correct. It's going to be greater than minus 9. Yeah. So the range of g of x is going to be greater than minus 9. Okay. And that's it. We're done with part F. Then it says state the domain of g of f. Okay. So for this, what you're doing here is, what you're essentially doing is that you're just combining two functions. Okay. So one function has domain greater than 0 and the other has greater than 1, okay? So as far as f of x goes, the domain of f of x is greater than 0, and the domain of g of x, the domain of f of x is greater than 1, and the domain of g of x is greater than 0. So what common area do they share? This is the common range. So that means when you combine the two, the combined domain would be x is greater than 1. And there you go. That's your answer. Okay, so whenever you're combining two functions, what you're looking for is the common domain. Okay, so f of x has domain x is greater than 1, g of x has domain x is greater than 0. Okay, so what is the one domain that suits both the functions? It's greater than 1. There you go. Showing all your working, find the exact solutions of g of f of x equals to 4. Okay, so first things first, let's find out g of f of x before we can set it equal to 4. So let's write down function g here, which is 4x squared minus 9. Let's write down f of x here, which is 5x minus 2. Okay, so now we combine the two, which means 4 into 5x minus 2, the whole thing square, okay, minus 9. So this is what g of f of x equals to look like, and this is equal to what? This is equal to 4. Not according to me, but according to the question. Okay, so 4 5x minus 2, the whole thing square, is equals to 4 plus 9, which is equal to 13. And then we make 5x square minus 2, 5x minus 2, the whole thing square equals the subject, which is equal to 13 upon 4. Now here's a quick question for you guys. What would be a good idea, to expand this and then solve it, or do you think it's better if I take the perfect square on both sides? Question for you guys. You can expand it and do it like that, by the way, okay? But a good idea would be to take the square root on both sides, okay, since you have a perfect square, okay? So 5x minus 2 equals to plus minus 13 upon 4, all right, square root of 13 upon 4. Then you make x the subject, okay? By the way, I think I said perfect square. I actually meant square root, okay? So 5x minus 2 is equals to plus minus square root of 13 upon 2. Now we make x the subject, and obviously we do that step by step. Don't try and do it directly. That's not something I would recommend. So we start by making 5x the subject. So in that case, it becomes square root of 13 upon 2 plus 2. Then we make x the subject, which means plus minus square root of 13 upon 2 plus 2 divided by 5, okay? And then when you're dividing it by 5, you change that to multiplied by 1 upon 5. And when you do that, let's see what happens. So this becomes x is equals to plus minus square root of 13 upon 10 plus 5 upon 5. There you go. So that means x is equals to plus minus square root of 13 upon 10 plus 1. And there you go. That's it. That's your answer. Sir, it's positive 2. What do you mean positive 2? Can you repeat? Did I make an error? 4 plus 9 is 13. 13 upon 4. Alright, let me know if you think I've made an error, made a calculation error or something. Okay. Anyway, so moving on to the next question. And the next question that I'm going to do, as you mentioned, is a question. Instead of plus 5, it's plus 2. Okay, let me check. Instead of plus 5, it's... Oh! Alright, so I always have a tendency of making errors like this. Yep, thank you. You're right. 2, 2. So that's going to be 2 upon 5. Okay, thank you. Thank you. Walaikum salam. Okay, so as I said earlier, that let's do a question that involves graph. Okay, so here's a question. All right. This says the function f is defined by f of x equals to ln 2x plus 1. So this will help you understand graphs of ln also. Okay. Sketch the graph of y is equals to f of x, and hence sketch the graph of y is equals to f inverse of x on the axis below. Okay. So notice how the question has already been kind enough to give you the domain. Okay. So we start by plugging in 0. Okay. So 2 times 0 plus 1, close the bracket. Let's see what happens. So you get 0. So that means when x equals to 0, all right, what ln is equal to, that's also equal to 0. Okay. There you go. And then we plug in 1. All right, so if you plug in 1, you get something like 1.09. So that means slightly above 1. Then you plug in 2. Notice what happens. So if you plug in 2, what you get is 1.6. So again, just above 1. And so halfway between 1 and 2. Okay. So there you go. Let me just remark the points. There and there. Okay, walaikum salam. Alright, and let's see what happens next. Then we plug in 3. Okay, now the whole idea of this activity is to sort of understand the shape of the curve. Okay, I'm not going to, I'm not basically making a plotting this, okay, or drawing this. We're making a sketch. All right, so keep that in mind. So 2 into 3 plus 1, close the bracket. So when you plug in 3, so the graph is just under 2. Okay, so it's around 1.9 something. So now that we have a good understanding of the shape of the curve, okay, so we're going to go ahead and join these points and make a nice and smooth curve. And when you do that, this is what it should look like. There you go. Okay, now the next thing you have to do is, I know some of the points are not on the line, but that's okay, nothing to worry about. Now here's a question for you guys. Whenever we're making the inverse, all right, whenever we're sketching the inverse function, what is the one thing we keep in mind? That, okay, so you guys can complete this sentence. Okay, I'll make it easier for you. The inverse is a blank. Okay, so Mohammed Anas has already answered that. Yes, thank you. So the inverse function is actually a reflection along the line y equals to x. Okay, and here's a quick question for you guys. What happens when you reflect a point along the line y equals to x? What happens when you reflect a point along the line y equals to x? To the points? All right, I get that. No, I get that. Yes. So x becomes y and y becomes x. Okay. So that means as far as the inverse goes, so 0, 0 will remain the same, and all the other points are going to be reflection. Okay, and obviously there will be a point which will remain the same, and that point is called the invariant point. Not that you guys will have to ever answer that, okay, but it's just good to know. For math, obviously, it's good to know, okay. And there you go. This is what the inverse will look like. So remember, something that you guys should always remember is that whenever you're asked to sketch f of x and also the inverse function, what you should clearly show is the relationship between the two. And what is the relationship between the two? The relationship between the two is that their reflection along the line along the line y equals to x. In fact, in some cases, the question will even ask you to describe the relationship or state the relationship between f of x and its inverse. Okay, so you got to remember that the relationship is that f inverse of x is the reflection along the line y equals to x. Okay, so there you go. That's it. This is question 9 part A done. Okay, here's another question. It says the function g is defined by g of x equals to x minus 4 the whole thing square plus 1 for x is lesser than or equal to 4. Okay, now for a question like this, again, it's always a good idea to sketch, see what the graph is representing, and so that you're more familiar with the shape of the curve before you write down the domain, range, whatever. Okay, so this curve will have turning point 4 comma 1. Okay, so somewhere here is 4, somewhere here is 1. Okay, and that this is what we're looking at. Okay, x comma y. Now, although as far as the quadratic curve is concerned, this is what the quadratic curve will be. But since we're, in fact, no, wait, this is not what we're looking at. What we're looking at, since it says lesser than or equal to 4, so that means this is what we're looking at, the other side. Okay, had it been greater than or equal to 4, then this is what we would have been looking at. Okay, but since it's not that, this is the part of the curve that we're looking at. Now, if I ask you guys to write down the range, now remember, we're talking about g of x. Okay, so as far as g of x goes, the domain, well, that's given to us clearly, x is lesser than or equal to 4. But looking at the curve, looking at the graph, if I ask you guys to write down the range, it becomes a lot easier for us to see what the range is going to be. And I'd like you guys to answer this question and tell me what will be the range. Yep, that's correct. It's not going to be greater than. In fact, it's actually going to be greater than or equal to 1. Okay, but I get what you mean. It's going to be greater than or equal to 1. Okay, so remember, what we're talking about right now is what? We're talking about g of x. Okay, now we find an expression for g inverse of x, for which we set the function equal to y. We write x minus 4 the whole thing square plus 1. Yeah, Anas Mashallah is quite a smart kid. So y minus 1 equal, good job Anas, x minus 4 the whole thing square. You've been answering pretty much all the questions correctly so far. So yeah. Okay, then we take the square root on both sides. So when you take the square root on both sides, in fact, before you take the square root on both sides, my suggestion would be to write it nicely. So we have x minus 4 the whole thing square equals to y minus 1. All right, now you take the square root on both sides. So now you're looking at x minus 4 is equals to plus minus. Now we will decide whether to go with plus or minus, okay, but in a minute. Thank you, Ibrahim. Appreciate that. X equals to plus minus square root of y minus 1 plus 4. Now we do the final step. Actually, not the final step, the second last step, and that is g inverse of x equals to plus minus square root of x minus 1 plus 4. Okay, now here's a question for you guys. And that is, are we going to go with plus outside the square root, or are we going to go with minus outside the square root? This is functions, just functions. Yes, we're going to go with minus. No, we're not going to go with plus, we're going to go with minus. Why is that? You're right, I can see that most of you have answered this correctly. That's great. But the question is, why is that? Why are we going with minus and why not plus? Yes, because of domain of g of x. Okay, so pay close attention to what I'm saying. All right. So basically, let's write down the domain and range of g inverse of x. Okay, so as far as the domain goes, the domain is going to be the same as the range. So that means x is greater than or equal to 1. All right. And as far as the range goes, the range is going to be the same as the domain, which is g inverse of x is lesser than or equal to 4. Okay. Now, if you're confused in between whether to go with the plus sign or the minus sign, so here's how you decide. So you look at the value that you look, so basically here's g inverse of x, and you know very well that the range of g inverse of x should be the domain of g of x, which is lesser than or equal to 4. Now think about it, you have a plus 4 over here, okay, and you got to make sure that this entire function is lesser than or equal to 4. So are you going to have a plus sign? If you have a plus sign and you add 4 into it, okay, if you have a positive value and you add 4 into it, what happens is that the value starts becoming greater than 4, okay. So if you want to make sure that this entire function stays 4 or lesser than 4, that means you got to have a minus outside the square root, okay. So overall this becomes 4 and then you minus something from it. So when you do that, the overall value of the inverse function is going to be lesser than or equal to 4, okay. Now a lot of people try to come up with these hacks that, okay, if this is less than, that means there's going to be minus, if it's greater than, that means it's going to be plus. I would not recommend that, okay. I would recommend to just follow this approach right here, that how do you make sure that the range of this function remains lesser than or equal to 4, and you do that by making sure that you have a minus sign over here, okay. If you had a plus sign, if you want to make things easier for yourself, you can sort of rearrange it to have a better understanding of what I'm saying. So this becomes 4 minus x minus 1. Now let's say you were confused in between plus or minus, okay. So what sign would you have to make sure that the range of this function is lesser than or equal to 4? The answer is, of course, minus, because only when you subtract something from 4, the overall range becomes lesser than or equal to 4, okay. So yeah, that's that. Okay, so I'm just gonna do, I think, let me see how many questions. Sir, B के लिए what score should I aim for? Well, पहली बात तो ये, why are you aiming for B to begin with? ठीक है. So yeah, that's that. Anyway, here's another question that I'm going to solve. This is from October-November 2017. Okay, and let's do this. So it says functions f and g are defined for x is greater than 0 by f of x equals to ln x, okay, and g of x equals to 2x squared plus 3. Write down the range of f. Okay, so ln function, what is the range of ln function? Question for you guys. Walaikum salam. What is the range of f? Okay, for this, it's a good idea to know what the graph of ln looks like. No, it's actually not greater than 0. This is what it looks like. I'm afraid, Anas, you've gotten one question wrong. But anyway, that's fine. Okay, this is what the graph of ln looks like. Remember that E and ln are basically a reflection of one another. So the graph that you're seeing in red is ln. The graph that you're seeing in green is E of x. Okay, so the range is going to be all real numbers. Okay, not just greater than 0. It's all real numbers. Okay. Now, however, this is for ln x. Okay, I think, Anas, what you've said is actually true. Okay, but I think you probably got confused between the two. Okay, so remember, even though x is greater than 0, okay, the range of ln is all real values. Okay, so I think you probably got mixed up between the domain and range, but anyway, nothing to worry about. This is what it's like. Okay, all right, part 2 says write down the range of g. So range of g, again, it's always a good idea to know what the function it looks like. 2x squared plus 3. So 2x squared plus 3 is a quadratic curve such that it's going to be entirely above the x-axis. Okay, and the turning point is going to be at 0, 3. There you go. Okay, so what is the range of this function going to be? The range of this function, remember that you're only allowed to look at this part because it's greater than 0. That means g of x is greater than 3. And there you go. That's it. That's your answer. Okay, now moving on to the next part. It says find the exact value. Okay, so whenever the question says find the exact value, remember finding the exact value means that if it's in square root, you leave it in square root. If it is in exponential terms, you leave it in exponential terms. Okay, all right, now part 3 says find the exact value of f inverse of g of 4. So we start by finding out, obviously we'll have to find out f inverse. Okay, so that we can do in a jiffy, honestly. So y is equals to ln x. Okay, let's write this nicely. ln x equals to y. Remember, the base of ln is e, so x is equals to e to the power y. And now we can do the final step, which is f inverse of x is equals to e to the power x. All right. Now we find out g of 4. So g of 4, again, we can do in a jiffy. 2 into 4 squared plus 3. So 4 squared is 16. 16 times 2 is 32. 32 plus 3 is 35. And now we find f inverse of g of 4. Okay, so that means we have e to the power of 35. And there you go. That's it. That's your answer. Okay, then we have g inverse of x and its domain. So g of x is 2x squared plus 3. So we start by making y the subject, which is equal to 2x squared plus 3. And y minus 3 is equals to 2x squared, which means y minus 3 upon 2 is equals to x squared. And now we make x squared the subject, which is going to be y minus 3 upon 2. X is equals to plus minus square root of y minus 3 upon 2. Now we have to go with plus or minus. So what do? We go back to the question. So the range of this function is going to be, in fact, first let's do the final step, which is g inverse of x is equals to plus minus square root of x minus 3 upon 2. Now, if you have to make sure that g inverse of x remains positive or remains greater than or equal to 0, okay, so what do? In fact, you're looking for the domain, right? Before that, remember that you got to make sure that g inverse of x is greater than 0. So if you want to make sure that this function remains greater than 0, you got to make sure that you go with the plus sign and not with the minus sign. Okay, so you can write plus, or you can just not write anything at all, which will automatically mean plus. And you also have to write down the domain. So as far as the domain is concerned, the domain of an inverse function is the range of the regular function. So the range of the regular function was greater than 3. That means the domain is going to be greater than 3 also. So there you go. That's it. That's done. Okay. Alright, so I'm just going to solve one more question, which is this one, and this is from October-November 2019, paper 12. So it's a different question. It's not your regular functions question. So it says identify each of the following with one of f inverse, g inverse, f of g, g of f, f square, g square. How'd you get turning point 3? So if you quickly convert it to completed square form, you don't really have to convert it to completed square form. You can actually tell that. So if you write it like this, 2x minus 0 the whole thing square plus 3, you can quickly see that the turning point is 0, 3. Or you can think about it this way, that if there is no x in the equation, then whatever the constant is, that is your y-intercept as well as your y-coordinate of the turning point. Okay. All right. So as I mentioned, that here's another question that I'm going to solve. Yeah, you could also do dy by dx, by the way. Okay. So it says you have to identify that what's what. So here's a question for you guys. How would you combine these two functions, or how would you use these two functions to get square root of x minus 5? Okay, so what do you think? You think it's going to be f of g, or you think it's going to be g of f? I don't know. What do you think? When doing dy by dx, you're getting minus 3 upon 4. I don't think that's possible. It's going to be, okay, I know why you're getting minus 3 upon 4. You're getting minus 3 upon 4 because you're just writing it as 4x. I think maybe you're writing it as 4x plus 3, and you're not turning 3 to 0 when you're differentiating it. You should get the same answer. You're probably making a calculation error. So just look into that. Anyway, so how do you use square root of x and square x plus 5 to make square root of x plus 5? So let's do a bit of trial and error. Obviously, it's not going to be inverse. Okay. So if you plug in g in f, okay, so in place of x inside the square root, you will have x plus 5. So that means as far as the first one goes, that's pretty simple. It's just going to be g of f of x. Okay, there's not really much thought required. Okay, you can just simply answer it like that. Now for part 2, obviously there's some thinking required. Now if you notice over here, you have x plus 5 as far as g of x is concerned, it's x plus 5. Now, how does this become x minus 5? So that means there is some element of inverse involved. The only time this 5 will become minus 5 is when you take it over to the other side. And when you do take it over to the other side, the only time you will do that is to find out the inverse. So that means this is g inverse. And then x square again, so root x, the exact opposite of square root of x is x square. And when does that happen? When does square root of x turn to x square? That is when you're taking the inverse. So that means this is basically equal to f inverse, and that's it. X plus 10. Okay, so we have x plus 5. What is it that we have to do for it to turn x plus 10? Now you can take help from here. Okay, now my obvious guess would be g square. Okay, and if there's any doubt, there's no harm in trying it. Let's try g of x. So x plus 5 in place of x, and then the plus 5 from before. Okay, so what does this become? This becomes x plus 10. Now you don't have to show this, you just have to write down the final answer, which is gg. That's it. Okay, b part 1, which says it is given that h of x equals to a plus b upon x square, where a and b are constants. Why is minus 2 to 2 not a suitable domain for h of x? Why do you think this is not a suitable domain? So part 1 is correct, isn't it? Fg, f of, okay, what did I write? Yep, it is Fg. That's correct. It's Fg. Thank you. Okay, Anas, yeah, I'm not surprised that you're the one to point this out. Thank you. Fg it is. Yes, so basically the reason why it's not defined is because there will be x equals to 0, and when x equals to 0, h of x becomes undefined. Okay, a nicer way to frame this would be that this contains x equals to 0. This range that you're looking at contains x equals to 0, and when x equals to 0, h of x becomes undefined. Okay, now here's a question. It says given that h of 1 equals to 4, so h of 1 equals to 4, so this is probably heading towards simultaneous equation. So a plus b upon 1 squared equals to 4, so this gives you your first equation, a plus b equals to 4. And then it says h prime of 1 equals to 16. So before I can find out what h prime of 1 is, I have to find h prime of x. Okay, and before I can do that, I have to first write it nicely, basically make it differentiation ready. Okay, so h prime of x equals to 0 plus minus 2b x to the power minus 2 minus 1, that's minus 3. Now we write h prime of x nicely, so this can be written as minus 2b upon x cube. Okay, and h prime of 1 basically means minus 2b upon 1 cube, and what is that equal to? That's equal to 16. So minus 2b is equals to 16 leads to the conclusion that b equals to minus 8. And once you have the value of b, please do not get carried away and think this is the final answer. You still have a to find. So a plus b is equals to 4. Remember, a minus 8 is equal to 4, which means a is equals to what? A is equals to 12. And there you go. That's it. That's your final answer. Okay, so that's it. I'm going to stop here. And I just want to say that whoever it is that has his or her exam tomorrow, at math exam, make sure to get enough sleep. Very important. You need a fully functioning brain tomorrow. And just make sure to read the question carefully. Make sure to revise all your notes, the formulas, and everything that you've done so far. Just do a quick revision of it. I would suggest do not try and attempt a full length past paper. Okay, you don't want to enter into a state of panic in case you're unable to solve all the questions carefully. Okay, so yes, definitely I'll pray for you guys. Best of luck. Let me know tomorrow when you're done with the exam exactly what all came as far as the topics are concerned, so we can prepare for paper 2, inshallah. Okay, so take care, boys and girls. Good luck. Have fun. See you soon. Allah.